Welcome to Study Loop.
Okay, so in this problem, in first part we are given 100-gram sample of a certain bronze, and we are said that a bronze is a solid solution of copper and stannum or tin. And in this 100-gram sample, we have 90% copper and 10% tin. We have to find out which metal can be called the solvent and which is the solute. So we know that in a solution, solvent is the component which is present in the largest amount or in larger amount, and the solute is the one which is present in the smaller or smallest amount. So here our percentage of tin is 10%, which is the smallest. That means our solute here is tin, and the copper being the larger or the largest portion, that means our solvent here is copper. Now in the second part of this problem, we have to find out the concentration of the solute metal in the alloy in units of molarity, assuming a density of 7.9 gram per cc. So what we have to do is, first we have to find the number of moles of the tin from its mass. So we know the mass of tin, since it's 10% of 100 gram, which will be 10 gram. So from the mass we can find the number of moles of tin, and then we can find the volume of the solution from its density and the mass of the solution, which is 100 gram. So from these two values we can find out the volume of the solution, and then from the number of moles of the tin and the volume of the solution we can find out the molarity of the tin or the solute in the solution. So first we'll find out the number of moles of the solute or tin, which is, so the mass is 10% of 100 gram, that means 10 gram over the molar mass of tin, which is um 118.71 gram per mole. So from here we can find out a value of 0.084 mole. So this is the number of moles of the tin which is present. Now we have to find out the volume of the solution. So the volume of the solution will be um, the mass of the solution over its density. So 100 gram over the density is 7.9 um, gram per cm cube. So this will give us a value of 12.6 cm cube. And as you know that 1 cm cube is 1 milliliter or 10 to the power minus 3 liter. That means we can write down it as 12.6 times 10 to the power minus 3 liter. So now we know the number of moles and volume. So from here we can easily find out the molarity of the stannum or tin or the solute, which will be equal to the number of moles over volume. So the number of moles here is 0.084 mole over the volume, which is uh, 12.6 times 10 to the power minus 3 liter, and this will give us a value of 6.67 mole per liter or molar. So this is the concentration or the molarity of the solute, which is um, tin in the bronze solid solution. Now in third part of this problem, we have to find out a reaction that we can do to remove all the tin from this bronze to leave pure copper sample. So one reaction we can do is we can add hydrochloric acid to this solid solution, and this hydrochloric acid will react with tin to remove this as stannous chloride, and hydrogen gas. So in this way, we can just remove all the stannous chloride from the solution, and we will remove only the pure copper. So the thing here is HCl will react with only tin but not with copper, because if we look at the reactivity series, stanamore tin is above hydrogen and copper is below hydrogen. That mean and we know that from the reactivity series that any metal or substance which is present above then another metal or substance, the above metal will be able to replace the metal or substance which is placed in lower than that metal or substance. That means tins being above hydrogen, it will be able to react with HCl to remove hydrogen and to produce SnCl2. But copper being or having a place which is below hydrogen, it will not react with hydrogen chloride or HCl, so there will be no reaction since copper is below hydrogen in the reactivity series, and that's why copper will remain as the copper in the solid solution, but tin will react with HCl and uh, will be removed from the solid solution mixture as SnCl2. So this way, by adding hydrochloric acid to the solid solution of bronze, we can remove stanam or tin to leave pure copper in the solution mixture.